Good morning. Today we're going to go over some basics of Earth and Earth's orbit. We'll include a little bit of the moon as well. So in this first image, what it's showing you, hopefully, is review. And it's showing you that the Earth goes around the sun. It makes one orbit per year. So it takes a full year in order to complete this one trip around the sun. Now the other planets take either longer or shorter, it just depends. What you'll notice about this image too is that we have an axial tilt. That is this tilt that you see here. Earth isn't straight up and down, it's actually tilted a little bit on its side, 23.5 degrees. And that axial tilt is going to point in the same direction throughout that whole orbit. All right? What that means is that it is pointing in this direction during summer, and it's still pointing in that same direction on the opposite side of its orbit during winter. That's going to be important. Down here, we have conditions where in the northern hemisphere where we live, the axis is tilted towards the sun, okay? If we're tilted towards the sun, we get more sunlight in the northern hemisphere. Now this is opposite in the southern hemisphere. You'll see that the northern hemisphere being tilted toward the sun, it gets, like I said, it gets more light, which means hemisphere, which means that the southern gets less. Now in the northern hemisphere here, since it's getting more sunlight for several months, this is what causes summer. Not how close or far away the Earth is to the sun. That has nothing to do with summer and winter. It's the angle of the Earth either pointed towards the sun or pointed away from the sun. So, northern hemisphere, we get summer when it's pointed towards the sun. Now, if we take a look at this image, it's the exact opposite. You can see the northern hemisphere, which is this top portion, is pointed away from the sun. So axial tilt away, and that means there's less sunlight hitting the northern hemisphere where we live. Now in the northern hemisphere, this is going to mean that we have winter. And that just is because you're getting less sunlight, less direct sunlight, not as much energy transferred. So in the northern hemisphere up here, since it's pointed away, this is when we have winter. Remember, the southern hemisphere is always opposite. So now it's getting more sunlight, it's going to have its summer. Australia is a good example. They have summers when we have winters and winters when we have summers. Okay, looking up into the sky, you'll see some different paths that the sun will take through the different seasons. And this is again because of the tilt, that axial tilt. So this changes day to day, but we don't notice it day to day. You can definitely see it though seasonally. So if you're comparing summer and winter, you can see the sun pretty clearly taking a different path through the sky. Now there's an exception to this. So we're in California. We see a summer arc that goes high overhead, and a winter arc that stays low on the horizon. It never reaches very high up above the horizon. The exception, though, is the equator. Since the equator is right in the middle, the axial tilt doesn't actually come into play. The equator always gets the same amount of sunlight every day, and the sun takes the same path through the sky every day. All right, last thing, let's look at the moon. The moon, to make one orbit around the Earth, takes 27 days. It's a little confusing because it looks like the moon only takes 1 day to go around the Earth. But remember, that's because the Earth is spinning, not because the moon is going around the Earth once a day. So 27 days to go from one part in its orbit to the same spot, one full orbit, 27 days. And in those 27 days, the Earth is spinning pretty rapidly, right? Around and around and around and around 27 times. This is much slower. Down here, we see the different phases of the moon. And we're not going to get into all of the phases, but what I do want to talk about is the fact that the moon is tidally locked to the Earth. What that means is the same face of the moon is always facing the Earth. Doesn't matter where it is in its orbit, and it doesn't matter where the sun is. It has the same side always facing Earth. And you can see this if you look at the moon from night to night. You see the different phases, the different shadows that go over the moon. But the craters that are very obvious on the moon, or the big regions of dark material on the moon, they stay in the same place night to night. No matter where that shadow goes, you're seeing the same features in the same locations. All right, hope this helps.